my name is Uğurcan Akdemir, and this is the part 2 of our presentation about Apache Cassandra. I will be talking about the parts that my friend Erginbay Kazancı left out, and I will start with the architecture of Apache Cassandra. So, like probably every other NoSQL DBMS, Apache Cassandra uses nodes, data nodes. And when at least two nodes are strung together, they are called a data center. They're basically a collection of data nodes. And when multiple data nodes are strung together, when they're synchronized, they are called a cluster. Well, technically, a single data center can also be classified as a cluster, but that's neither here nor there. So, Apache Cassandra uses something called a commit log, which every committed operation is logged in. It is a log. It records every single write operation, and one of the main benefits of doing things like that is that at the event of a crash, a system crash, knowing what has been committed really helps. After the commit log, the data is written into something called a memtable. And in these memtables, there can only be one for a single column family, as we've seen. And basically, it is what has been defined as a memory resident data structure. Data is written into the memtable, and after the memtable is full, we will see what will happen. So there is also something called an SS table, and it is a disk file. Data is flushed into from the memtable when its contents reach a threshold, basically. So as we can see, this is a figure about the architecture. Writes and updates go through the memtable. They are flushed into the SS tables. Read operations can take place anywhere. Commit log and memtable are always in operation together. So about the distribution aspects of Cassandra NoSQL or Apache Cassandra, we have the cap theorem. It states that any NoSQL database management system can only have at most two of the three adjectives of consistency, availability, and partition tolerance. And in the natural case of Cassandra NoSQL, it is an AP, an available and partition tolerant DBMS. But one of the many good things about Cassandra is that it can be tuned in order to sacrifice partition tolerance and go more in the direction of consistency. So if a user's work demands it, partition tolerance can be sacrificed for consistency, and certain other businesses would certainly prefer that. So that is another big plus about Cassandra. Moving on. So about data versioning. What data versioning means is that some certain elements or some data, old versions of some data might be, need to be preserved in order for a second look perhaps in the future, or in the case of a loss of data, it can be easier to retrieve certain useful parts of data. But in its normal states, Cassandra NoSQL does not support data versioning, but a simple workaround to that is that we can actually store data like we would normally, and as we know, there are one of the attributes of every single column in a row is that there is something called a timestamp. We can basically put a timestamp on a piece of information so that we know when it has been last updated or worked on. we can actually, this is maybe a primitive way of doing this, but we can actually save this, the data that we want to save for future second logs, and we can distinguish it with the timestamp on it, and we can know when that data was last worked on or last updated. So in its normal states, Cassandra NoSQL unfortunately does not support data versioning. So we can also say that Cassandra NoSQL uses row-level isolation, which means that when a write operation is taking place on a row, other users can actually view the rows that are not being written on. They can't change anything when those rows are being worked on, but they can view them, but not the rows that are being worked on. They can't view them, they can't change anything. The other users have to wait for their turn. They can view other columns or rows as they wish, but not the ones that are being worked on. Now, Cassandra NoSQL Apache Cassandra supports two replication strategies, and one of them is the simple strategy, so named. It is, as we can understand, a simpler strategy that is usually used by those that do not have a high number of nodes. It's a simpler, more primitive, workaround for replication strategies, or what might be. The other more powerful one is, of course, the network topology strategy, which is actually better when working with more complex systems, when more complex data centers and whatnot. So simple strategy actually places the first replica in a node, and new replicas are placed next to it on the next nodes. As you can see on the figure, it is a pretty straightforward, simple strategy. There is not much to it. When it comes to the network topology strategy, replicas are placed in the same data center, and you can see on the figures over there, it is actually more complex. But in case of failure in case of loss of multiple data, this would work better. This would work better to probably prevent something like that. So it is obvious why some people would want this over the simple strategy. About the distribution aspects of Cassandra, we can actually provide inputs to a custom-made probably program in order to use the MapReduce programs and strategies. Cassandra on its own doesn't do it. There are no other systems, but it is still technically possible. So about transactions, the Cassandra does not support the ACID properties, actually, and certain types of transactions actually become impossible because of that, but everything has its good and bad sides, as we know. Certain people, while I was actually doing the research about this project, certain people have claimed to have found workarounds. I cannot know how and why, but I also need to question the reliability of their claims. But the supported type of transaction is the lightweight transaction. It is actually possible with Cassandra. We can actually do that. As was talked about, Cassandra was created to run fairly efficiently and fast on even low-end systems. One of the benchmark results that we have been able to find is, as you can see here, writes and reads averages are there. Writes are super fast, which is one of the main selling points of Cassandra, which is why it was designed. So we can see that it is actually more preferable when compared to something like MySQL. I don't know really how fair that comparison is, knowing that those two are completely different things, but there you go. So that is going to wrap up my part about Cassandra NoSQL, Apache Cassandra. These are some of the references, if anyone would like to check them out. My name is Uğurcan Akdemir. Thank you for your time. Thank you for listening. I hope that I will see you around. Thanks again.